What if you could break things on purpose, learn fast, and never risk your real network? Welcome. Imagine breaking things on purpose with no consequences. That's the basic magic of a home lab. It's a private sandbox where you build servers, networks, and experiments. You test hacks, deploy apps, and learn real troubleshooting. No production outages, no furious emails, only snapshots and resets. Over the next chapters, you'll pick hardware, stack software, and design safe networks. First, we choose the right starter for your goals. Why build a home lab? Because hands-on beats theory every time. You'll practice firewalls, routing, and web exploits without risk. You'll deploy CI pipelines and watch metrics in real time. Recruiters love concrete projects, not buzzwords. A weekend snapshot of a working app can be a job interview highlight. Decide what you want in 60 days: security, networking, or DevOps. Which path fits your next resume move? Safety first. Set guardrails before you spin any attacker VM. Only test systems you own or have written permission to test. Isolate the lab from your home network with a separate subnet, VLAN, or router. Disable bridging and restrict outbound internet from vulnerable VMs. Use strong, unique passwords and snapshot often. Keep logs so you can retrace mistakes and learn. Ready to pick a simple plan that stays safe? Plan before you buy. Spend 5 minutes writing one clear goal for 60 days. Want to learn penetration testing, routing, or CI/CD? Pick a run mode: virtual only, small physical gear, or hybrid host plus devices. Start with one host and 3 VMs. That configuration teaches most skills. Scale later when your goals demand it. Let's choose the hardware that matches that initial plan. You don't need a noisy rack on day one. Reuse your current laptop, upgrade RAM, and run VirtualBox. Consider a mini PC or refurbished small form factor desktop with 32 gigabytes when you need power. Raspberry Pi works great for lightweight services and sensors. If you want enterprise practice, a used Dell rack server can come later. Think quiet, efficient, and power-friendly, not horsepower for its own sake. Next, we pick the software stack. Software choices shape what you can learn quickly. For virtualization, start with VirtualBox or VMware Workstation. For a home server, try Proxmox to run VNs and containers. Use Docker or Podman for apps, and K3s or Kind for tiny Kubernetes clusters. Add Portainer for UI comfort, and Git for version control. Automate with Ansible or Terraform when you repeat setups. Curious which of these to install first? I'll show a practical sequence. Network design is the backbone of a safe lab. Use a dedicated lab subnet like 192.168.50.0/24 and route traffic through a firewall VM. Block inbound connections and allow only needed outbound flows. Segment IoT, LAD, and personal devices with VLANs. Run your own DNS and DHCP for lab hosts. These patterns stop accidental exposure and teach real engineering trade-offs. Ready to wire up a firewall and DNS next? Firewalls and DNS give you control. Use pfSense or OPNsense as a virtual appliance to route and secure traffic. Pi-hole makes DNS filtering simple and visible. Add WireGuard to access the lab remotely without exposing services. For packet insight, run Wireshark on captures or mirror traffic to a sensor. These tools let you see what devices actually do. Next, we stand up your first ethical hacking playground. Let's build a safe security lab. Create an isolated virtual network with no bridge to your home LAN. Deploy an attacker VM like Kali and targets such as Metasploitable or OWASP Juice Shop. Add a monitoring VM like Security Onion or Wazoo to collect logs. Snapshot each VM before testing so you can revert instantly. Operate entirely inside the lab, no external scanning. What should you practice first inside the zone? Start with recon and enumeration. Use the OWASP Top 10 as a checklist for web app flaws. Practice credential hygiene and implement lockouts on lab machines. Conduct log analysis in Security Onion and tune alerts until noise drops. Map each activity to MITRE ATT&CK to build real workflows. These exercises mirror professional incident response and penetration testing. Want guided scenarios instead of starting from scratch? Guided platforms accelerate learning. Try HackMe gives structured labs and walkthroughs for beginners. Hack the Box scales to realistic adversary scenarios. Over the Wire sharpens fundamental Linux skills with war games. Use these platforms inside your isolated lab to practice techniques safely. They provide scoring, hints, and community support, perfect for staying motivated. Next, let's design a DevOps corner in your lab to learn delivery pipelines. For DevOps, assemble a mini production stack. Start with Git for source control and a local runner for CI, like Jenkins or GitHub Actions. Use Docker and Portainer to manage containers. Deploy a small K3s cluster for orchestration experiments. Add Prometheus and Grafana for monitoring and dashboards. Integrate HashiCorp Vault for simple secret handling. This setup teaches the full delivery lifecycle from code commit to production metrics. Ready to build a starter project? Starter project idea. Build a simple REST API, containerize it, and push to your CI pipeline. Let the pipeline build images, run tests, and deploy to K3s. Instrument the app with Prometheus metrics and visualize latency in Grafana. Add a health check and an automated rollback on failed deployments. This gives end-to-end experience you can demo in interviews. Next, we zoom into networking labs for routing and troubleshooting. A networking lab teaches real troubleshooting muscle memory. Use GNS3 or EVE-NG to emulate routers and switches and practice OSPF or BGP with FR routing images. Configure VLANs on a managed switch and test inter-VLAN routing with pfSense. Use iPerf3 for throughput tests and Wireshark for packet-level analysis. Design a user's, server's, DMZ topology and practice failure scenarios. Want tips for quiet, efficient hardware that won't punish your apartment? Hardware matters beyond specs. A quiet Milli PC with 32 gigabytes of RAM often beats a noisy 1U server at home. Watch power use and heat. Old enterprise gear can spike your electric bill. Consider SSDs for speed and a UPS to protect snapshots during outages. If you buy used, inspect fans and measure noise at idle. These choices affect how often you actually use the lab. Next, let's explore a fun but safe IoT lab. IoT labs are delightful and mischievous. Run Home Assistant on a separate VLAN and connect a Zigbee or Z-Wave hub. Spin up an MQTT broker like Mosquito and test integration safely. Apply firewall rules to restrict IoT to the internet and block access to your personal network. Monitor device traffic with Security Onion or Zeek to spot odd behavior. This teaches segmentation and policy without risking family devices. Next, we lock in workflow habits that save time. Repeatability wins. Use Git for all configs and store architecture diagrams in a repo. Snapshot VMs before changes and maintain a lab README with IPs and credentials. Automate repeat setups with Ansible or Terraform so you can rebuild quickly. Back up important configs to a NAS or cloud storage. Keep a changelog for experiments that went sideways. Little habits compound into huge time savings. So which habit will you adopt first? Turn your lab into career currency. Publish short blog posts about projects and the trade-offs you made. Open source Terraform or Ansible configs without secrets. Record a 2-minute demo video showing your topology and dashboards. These artifacts beat buzzwords in interviews. Prepare cert-relevant labs for CCNA, Security Plus, or Cloud Fundamentals and map activities to NIST NICE roles. Ready to avoid common pitfalls that slow most beginners down? Avoid these traps. Don't bridge vulnerable VMs to your home LAN, and never reuse weak or default passwords. Don't overbuy hardware before you understand needs. Keep systems updated and backups current. Track power, noise, and heat if you're using older servers, and document. You will forget manual steps in a month. These simple safeguards keep your lab useful and safe. Now, let's follow a concrete 30-day roadmap you can finish. Week 1. Foundations, install VirtualBox or Proxmox and create a dedicated lab network. Spin up 2 VMs and confirm isolation from your home LAN. Set up Git and push a simple README describing goals and IPs. These small wins set a reproducible baseline you can expand. By the end of the week, you'll understand your host, the virtual network, and a recovery snapshot. Next, we'll outline Week 2 networking and security tasks. Week 2, networking and security. Deploy pfSense or OPNsense as your gateway. Add Pi-hole for lab DNS filtering and spin up Kali and a vulnerable target like Juice Shop on an isolated subnet. Practice safe scans and enumeration inside the lab only. Snapshot everything before tests and route logs to a monitoring VM. These exercises teach separation and attacker thinking in a controlled way. Next, Week 3's DevOps and Observability focus. Week 3, DevOps and Observability. Install Docker and Portainer. Deploy a simple app. And add Prometheus plus Grafana. Build a CI pipeline that runs tests and builds container images on commit. Create a dashboard for CPU, memory, and latency to visualize real impact. Week 4, Moja's Blue Team tasks and portfolio creation. What will you show in your demo video and blog post next? Week 4, Blue Team and portfolio. Deploy Security Onion or Wazoo. Generate alerts and tune detection rules. Analyze logs, map incidents to MITRE ATT&CK, and document your playbook. Write a concise blog post and publish configuration snippets without secrets. Record a 2 to 3 minute walkthrough, demonstrating topology and dashboards. By day 30, you'll have a complete, demonstrable lab ready to iterate for months. Ready to bookmark tools and resources next? Final recap. Start small, isolate everything, document each change, and snapshot before risky moves. Use inexpensive hardware like mini PCs or a repurposed laptop. Combine VMs for security labs and containers for DevOps. Practice on guided platforms, publish your work, and map skills to certs that matter. The most important move is to start tonight with one VM or one container. Which starter project will you try first? If this roadmap helped, like the video. Subscribe for more step-by-step lab builds, and comment which starter project you'll try so I can recommend next steps.